Hi everyone, today we're going to work on lesson 4, balancing chemical equations. So before we get to balancing chemical equations, I do want to take just a minute to remind us all of what our subscripts in our chemical formulas really mean. So let's take a look at some of these. In our first example, we have calcium chloride, CaCl2. This means, because there's no subscript in front of calcium, that I have one calcium atom, and the 2 down here means I have 2 chlorine atoms. When I move on and take a look at calcium hydroxide, keep in mind this 2 and these parentheses are around the OH. So I still have just one calcium here, but now taking into account both our parentheses and our 2 subscript, I have 2 oxygens and 2 hydrogen atoms. Okay, looking at our next example, calcium phosphate. The 3 subscript next to the calcium means I have 3 calcium atoms. The 2 essentially gets distributed through the parentheses. So without the 2 here, I would have 1 phosphorus. With the 2 there, I have 2 phosphorus. Without the 2 here, I would have 4 oxygens. With the 2 here, this gets multiplied through. I now have 8 oxygens. And finally, with our last example, again, multiplying through, I have 2 nitrogens. I have 8 hydrogens. I have just 1 sulfur. And I have 4 oxygens. Hopefully you recognize without parentheses, the subscript only applies to the element that it's next to. When I add parentheses in, that subscript then gets distributed to each of the elements inside of the parentheses. Okay, so now let's take a look at what adding a coefficient does to the number of each atom. So I'm just going to pretend that we have 2 of these and 3 of these. When you put a coefficient, a number that's out in front, which is what we're going to use to balance equations, that coefficient is similar to a 2 or a 3 in a mathematical expression. So if I had 2x, that means I have 2 times x. So here I have 2 times everything that comes behind it. So 2 Na2SO4s. So I'm just going to draw for you what this would look like. So Na2SO4, imagine, looks like this. If I put a 2 out in front of it, that means I have 2 copies of this entire thing. So with a 2 out in front, I have 4 NAs, I have 2 sulfurs, and I have 8 oxygens. I essentially have 2 copies of this entire compound. Okay, in our second example, I'm going to put a 3 out in front. So putting a 3 out in front multiplies through, so I now have 9 strontium. We take a look at the next part. I have 2 phosphorus, but now with a 3 out in front, I have 6 phosphorus. I have 6 oxygen, 2 times 3. But now with a 3 out in front, I have 18 oxygen. So the 3 gets multiplied throughout the entire thing. So just real quick, the purpose of balancing equations is because chemical reactions must follow the law of conservation of mass. So basically what that means is whatever amount of material you start with, you have to end up with the same amount of material. So if I have 5 oxygen atoms on the left side, the reactant side of my chemical reaction, I have to wind up with 5 oxygen atoms on the right side when the reaction is all done. Now, I'm going to offer 2 recommendations for balancing reactions. So the first one is to balance hydrogen and oxygen last. They are often located in multiple spots in a chemical reaction, and it's very difficult to balance them correctly if you start with them. So by waiting to the end in order to balance hydrogen and oxygen, you kind of balance some of the other materials and it works itself out. It's not 100%, but that's often the case. The second thing is when you have a polyatomic, like we saw sulfate or phosphate, sometimes that appears as one thing on both sides. So if you have calcium sulfate on one side, and on the other side you have sodium sulfate, you can treat that sulfate as one thing and balance it as one unit. Sometimes that helps making balancing a little easier. Okay, let's take a look at the examples that we have. So in our first problem, we're going to start on the left side. A reminder that your equation has to be balanced on both sides of our arrow. So our arrow is what separates the reactants and the products. So our arrow is what is used to balance out an equation. So on the left side of the arrow, I have 1 carbon. On the right side of the arrow, I have 1 carbon. On the left side of the arrow, I have 2 oxygens. On the right side of the arrow, I have just 1 oxygen. Now, what you cannot do is add a subscript. So what I can't do is say, oh, I need 2 oxygens over here, so I'll just put a 2 here. You're not allowed to do that because that changes the compound that you're talking about. So instead, what you have to do to get 2 oxygens on the right side is to put a 2 as a coefficient. Now, the problem with balancing equations and what makes it so challenging is you have to constantly kind of bounce back and forth between the reactant and product sides. So in our case, we have 2 oxygen and we have 2 carbon. So I'm going to put a 2 over here on the left side. And now notice that I have 2 carbon, 2 carbon. I have 2 oxygen. There's nothing here, so essentially that's a 1. So I have 2 oxygen here, and I also have 2 in front of CO, so I have 2 oxygen on the right side as well. The takeaway message from this example is to go back and check your work. Sometimes you inadvertently change the number of a particular atom that you might have balanced earlier. So when you get to the end and you're all done, go back and check your work. Let's take a look at example number 2. To start off, we have 2 carbons on the left. We have 2 carbons on the right. We have 2 hydrogen on the left and 2 more, so that's 4 hydrogen. We have 6 hydrogen on the right. Now, what we don't want to do is mess with carbon since that is already balanced. So in order to get up to 6 hydrogens on the left side, the only thing that I need to do is to put a 2 here. Now I have 2 hydrogens plus 4 hydrogens for a total on the left side of 6 hydrogens, and I have 6 hydrogens over here. I didn't change carbon, so I still have 2 here and 2 here. So I can fill in these with 1s once we're done, or you could just leave them blank. Let's take a look at our third example. In our third example, we have C2H6 again. It almost looks like this is the reverse of the previous problem, but it's not. So we have 2 carbons on the left. We have 2 carbons on the right. We have 6 hydrogen on the left. We have 4 plus 2 more, 6 on the right. The purpose of this problem was to show you that occasionally an equation can be balanced and you don't have to do anything to it. So that is what we have here. In this case, we can simply add 1s all the way across. In our fourth example, I did go ahead and number all of these. In our fourth example, we're going to take a look at this equation. So I have 2 carbons on the left side. I have just 1 carbon on the right. So I'm going to go ahead and put a 2 there. I have 6 hydrogen on the left side. Right now I have 2 hydrogen on the right. So I'm going to put a 3 here. That will bring me up to 6. So 2 carbons, 6 hydrogen, 6 hydrogen. The last part is to balance oxygen. So I have 4 oxygen here and 3 more coming from water. That gives me a total of 7 oxygen. That doesn't work, right? Because on the left side, oxygen is always coming in 2s. So I could have 2, I could have 4, I could have 6, I could have 8, but I never hit 7. So when this happens, essentially what I need here is a 3.5. But when this happens, what I want you to do is to double all of your coefficients. So if we take a look at what we have now, doubling our coefficients, the 1 here becomes a 2. The 3.5 becomes a 7. The 2 becomes a 4. And the 3 becomes a 6. Once I have doubled everything, go back and check to make sure that it still balances out. So now I have 2 times 2, 4 carbons. I have 4 carbons on the right side. I have 2 times 6, or 12 hydrogen. I have 6 times 2, 12 hydrogen. Finally, oxygen. I have 7 times 2, or 14 oxygen. Here I have 4 times 2, or 8, plus 6, for a total of 14. So it does balance out, but you may have to double everything in order to get rid of that decimal. Your final answer should not have any decimals as coefficients. So if you do, you have to multiply to get rid of that decimal. Let's take a look at problem number 5. We have 2 nitrogens on the left. I'm going to go ahead and put a 2 in front of my nitrogen or ammonia over here on the right. I have 2 hydrogens on the left, but I have 6 hydrogens on the right. So in order to get 6 hydrogen on the left side, I have to put a 3 here. Now, notice, I have 3 oxygens on the left side. I have 2 oxygens on the right. So really what I need to do is put a 1.5 here. But again, we're not going to keep any decimals. So in this case, what we're going to do is we're going to double everything. So the 1 will become a 2, 3 will become a 6, the 2 will become a 4, and the 1.5 will become a 3. Now let's take a look at our equation. We have 2 times 2, that's 4 nitrogen, 4 nitrogen. We have 6 times 2, that's 12 hydrogen, 12 hydrogen. We have 3 times 2, which is 6 oxygen, and we have 6 oxygen right here. Finally, let's take a look at problem number 6. We have 2 carbons. So I'm going to put a 2 in front of carbon dioxide. We have 6 hydrogen. So sometimes equations have the same element written in multiple spots because of the structure. So we have 6 hydrogen. So I'm going to put a 3 in front of water to get 6. And finally, if you look at oxygen on the left side, we have 3 of them. Let's take a look at oxygen on the right side. We have 4 here plus 3 more for a total of 7 oxygen on the right side. Now, without disturbing anything else, we have to get 7 oxygen on the left side. So we have 1 oxygen here. We need 6 more. So I can go ahead and put a 3 on this line to get 6. So now let's double check. 2 carbons, 2 carbons. 6 hydrogen, 5 plus 1 more, 6. 6 hydrogen here. 6 oxygen plus 1 more is 7. I have 4 oxygen plus 3 more is 7. Okay, what I would like you to do for these problems is to try these on your own. So I'm going to ask you to pause the video, try these problems on your own, and when you're ready, you can press play and we'll go over these together. Okay, hopefully you've had a chance to work through all of those problems. We're now going to go over these problems together. So if we take a look at our 7th example, we have 2 nitrogens on the left. So that means I'm going to put a 2 on the right. We have 6 hydrogen on the right side. We need to get 6 hydrogen over here. So I'm going to put a 3 there. That should balance everything, so just double checking. 2 nitrogens, 2 nitrogens. 6 hydrogen, 2 times 3, 6 hydrogen. Let's take a look at our problem number 8. I have 1 potassium, 1 potassium. I have 1 chloride, I have 1 chloride here. I have 3 oxygen, and I have 2 oxygen. In an example like this, where it's 2 on one side and 3 on the other, use the least common multiple, in this case, 6. So to get oxygen up to 6, I'm going to have to put a 2 out in front. To get oxygen up to 6 over here, I'm going to have to put a 3 out in front. Now going back and balancing, I have 2 potassium, so I need to put a 2 here. I have 2 chlorine, and now I have 2 chlorine. So this equation is balanced. Let's take a look at problem number 9. We have 1 sodium, we have 1 sodium. We have 1 chlorine, we have 2 chlorines. So in order to fix that, we have to go back and put a 2 here. Now, when I do that, that changes my number of sodiums. So now I have 2 sodiums. So now I have to go back to this one and say, oh, I have 1 sodium here. I need to put a 2 in front of that as well. So I have 2 sodiums here. And finally, I have 2 fluorines, and I have 2 fluorines. So I can finish that off with a 1. So 2 sodiums, 2 sodiums. 2 chlorines, 2 chlorines. 1 F2, that's 2 Fs, and I have 2 Fs, 2 fluorines right here. Let's take a look at number 10. I have 2 hydrogens on the left, 2 hydrogens on the right. 2 oxygen on the left, but just 1 oxygen on the right. So I know I'm going to need to put a 2 here. That, of course, changes my number of hydrogens. Now I have 4 hydrogens on the right side. So I need to put a 2 here. Let's take a look at number 11. I have 1 PB. I have 1 PB. I have 1 Cl. I have 2 Cls. So I know I'm going to need to put a 2 in front of the HCl. Now I'm ready to look at my numbers of hydrogens and oxygens. So first, I'm going to look at my number of oxygens. I have 2 oxygen here. I have just 1 oxygen here, so I know I'm going to put a 2 there. And finally, I have 4 hydrogen. Here I have 2 hydrogen, and here I have 2 more hydrogen, so I have 4 total. So I can fill in these blank spaces with 1s, and now I'm going to go back and double check everything. So I have 1 lead, I have 1 lead. I have 2 oxygen here, 2 because it gets distributed through the parentheses. So 2 oxygen here. I have 2 waters, so I have 2 oxygen here. I have 2 hydrogen here, plus 2 more hydrogen. That's a total of 4. And I have 4 hydrogen here. And finally, I have 2 chlorines here. And I have 2 chlorines here. That is all balanced. Looking at number 12, I have 1 aluminum. I have 2 aluminums. So I'm going to take my AlBr3 and put a 2 in front of that. So now I have 2 aluminums. I have 6 bromine, 2 times 3, 6 bromine. So I'm going to put a 6 in front of KBr in order to get 6 bromine over here. Back on the left side, I have 2 potassium. But on the right side, I have 6 potassium. Once I put that 6 there, moving forward, there are no longer 1 potassium here, there are 6 of them. So I have 6 potassium on the right side. That means I need to put a 3 in front of the K2SO4 in order to get 6 potassium on the left side. Finally, I have 3 sulfates. Sulfate appears the same way on both sides. On the left side, once I stuck the 3 there, I now have 3 sulfates. On the right side, I have 3 sulfates. So I can go ahead and put a 1 here. Double checking. I have 2 aluminum. I have 2 aluminum. I have 6 bromine, 2 times 3. 6 bromine, I have 6 bromine. 3 times 2, 6 potassium. I have 6 potassium. 3 sulfates, so 3 times K2SO4. Each K2SO4 has 1 sulfate, but I have 3 of them. So I have 3 sulfates, and here I have 3 sulfates. And we'll finish up with example problem number 13. So I have 1 carbon, 4 hydrogens, just 2 hydrogens here, so I'm going to put a 2 in front. Now looking at oxygen, I have 2 oxygens here, but on the right side, I have 2 plus 2 more, 4 oxygens all together over here. So I'm going to put a 2 in there. We'll put in 1s here and here. Let's go back and double check. I have 1 carbon. I have 1 carbon. I have 1 times 4, or 4 hydrogen. I have 2 times 2, 4 hydrogen. I have 2 times 2, 4 oxygen. And here I have 2 oxygen, and here I have 2 oxygen. So 2 plus 2 more is 4, 4 oxygen altogether, 4 oxygen over here. Please try the balancing chemical equations homework. Let me know if you have any questions. I'll post the answer keys so that you can check your work. Have a great week, everyone.